Hello everyone, welcome to the discussions of the past year questions. This video we shall discuss about the further pure paper 1, May-June 2024, paper 13. Let's take a look at the first question. The matrix A is given as following here, where the K is a real constant. Show that the A is non-singular. So to show that A is non-singular, we just need to find the determinant of the matrix and show that the determinant is not equal to 0. Okay, so first of all, we write like this. This is the symbol for finding the determinant. We cannot say not equal to 0 directly. We need to show that they are not equal to 0. So the formula for determinant will be k multiplied by negative 5k minus a 6 minus a 1 negative 6k plus 2 plus a 0. So expand, you get negative 5k squared minus a 6k plus a 6k minus a 2. This one cancel. At the end, you get this. So from here, it's very obvious that they cannot be equal to 0. Like this, then therefore, just say that A is non-singular. Shown. So this is the answer for the part A. Now for the part B, they asking you to find the value of K, given that the inverse of the matrix A look like this. So what you need to do here is that we need to understand that the relationship of A and A inverse is when you multiply them together, you will get an identity. Okay? Or you can just write A inverse multiplied by A, you will also get identity. So you can choose either one. So I choose the first one. A multiplied by A inverse will give me the identity. So I just write the matrix like this. Identity will be 1, 0, 0, 0, 1, 0, and 0, 0, 1. So the A will be K6 negative 1, 1, 5, 3, and 0, 2 negative K. A inverse, just copy down here. A inverse. This one will be 3, 1, and negative 23 over 2. 0, 0, half, negative 1, 0, 3. So if you are going to find the value K, by right, these two multiply together, you're supposed to get this because this is given by the questions. So we just follow the instructions. So what you can do is just need to do one of it. I don't need to multiply all the 9 elements here. So I just need to multiply the first row and the first column here. Just need to multiply by the first row. The first row multiplied by the first column, then I will get this result of 1. There's no need for me to multiply all the 9 of them and then to compare. So just take the first row. So by comparing, the first element, then I get 3k plus 1 minus a 0 equals to 1. So from here, you get the k equal to 0. Done. So at the end, the k is a 0. Okay, so this will be the answer for number 1B. Now we're moving to the second question. Okay, now we take a look at question number 2. The cubic equations x cubed plus 2x squared plus 3x plus 1 equal to 0 has the root of alpha, beta, gamma. Then the question wants you to find the new cubic equations where the root is alpha squared plus 1, beta squared plus 1, and gamma squared plus 1. So what we need to do is at first we just let the substitution y equal to the x squared plus 1. So from here you can get that the x equals to plus minus square root of y minus 1. But we only consider the positive square root will do. I don't need to consider the negative because of later I need to square it Okay, I need to square the square root. So after I square the square root, the negative will become positive. So there's no need for me to put a positive negative square root. So now we just copy down the cubic equation that we have. And just change substitute x inside here as the y minus 1 power half. Square root means power half, so I make it become power half. I will get power 3 over 2. So this one is a power of 1. This one is the power of half. So the one with the power that is not integer, I will put it at one side. The one that the power is integer, I put it at one side. So I will get this. Square both sides. Squaring both sides like this. Then just expand them. You will get this one as a y minus 1 power 3 plus a 6 of y minus 1 square plus the 9 of y minus 1 is equal to the 4y square minus a 4y plus 1. Expand by using the binomial expansion. Then you get 6y square minus the 12y plus a 6 plus the 9y minus a 9 equals to the 4y square minus 4y plus 1. So join everything together, group everything together at one side. So you will get this one as a negative y square plus a 4y minus a 5 equal to 0. So this is how you get the answer for the question 2A. Okay, so now we move on. And B. Okay, yeah, all correct already. So now we go for the B. You have they want you to find this. So this one based on the root that we have, because the root that we have over here, all the root that we have over here is alpha square plus 1, beta square plus 1, and gamma square plus 1. So in order to find the square of all the new root over here, so just need to apply the formula. So we have alpha square plus 1 square plus the beta square plus 1 square plus the gamma square plus 1 square. This actually equals to the alpha square plus 1 plus the beta square plus 1 plus the gamma square plus 1 minus the 2 of the alpha square plus 1 multiply beta square plus 1 plus the alpha square plus 1 multiply gamma square plus 1 plus the beta square plus 1 multiply gamma square plus 1. This is the formula. So it will be the same as this one. I forgot to square it. So this is the sum of the roots. The sum of the root is over here. This is the sum of the root. Okay, so it's a positive 1. And then you square it. Then this part, whole thing over here, it will be the sum of the sum of the product of two roots. So it will be a 4. So this will be a 4. So at the end, you get 1 minus 8. You get a negative 7. That is the answer for the B. Then go for C. To go for C, we need to find the cube of the new root. The sum of the cube of a new root. So what you need to do here is, first of all, we define that this is called Sn, our n. Okay, so first of all, we define this. Then our y cube minus a y square, our equations at the part A, minus a y square plus 4y minus 5. I make it become y cube equals to the y square minus a 4y plus 5. Then from here, I will get S3 equal to the S2 minus a 4S1 plus the 5S0. So this is S3. So I'm looking for the what is the value of S3. So how do you find S3? To find S3, first of all, we need to have S2. So S2, this one, S2 is actually the answer from the part B. Answer from the part B, the answer is -7. So we just put -7. S1, this is S1. This one is S1. So S1 is a 1. Then S0. S0 means is this one power 0. Power 0, power 0, power 0. So power 0, you get a 1 plus 1 plus 1. So you get a 3. Then just press the calculator. You get a -11 plus 15. You get a +4. Done. Just like that. This is the answer for the number 2, C. Moving on, we have question number 3. Okay, now we take a look at question number 3. The matrix M is given as the product of two matrices here, and these two matrices represent the sequence of two geometrical transformations in XY plane. So they want you to give a full descriptions of each transformation and make clear the order in which they are parallel. So over here, you need to understand that the one at the most right-hand side is the first one, and then followed by the first one. Okay, so that means we need to look at this one as the first transformation. This transformation, you need to you can actually memorizing the result of the matrix here over here. So this is actually a stretch, okay, parallel to the x-axis with a scale factor of 7. So just start from here. Just say that it's a one-way stretch. Okay, parallel to x-axis with a scale factor 7. Okay, so this is the first transformation. Then we use a keyword followed by. So the keyword is followed by the second transformation, followed by what? Followed by this transformation. So this transformation is shear. Okay, so this shear is, this is a 2. Okay, that means originally 1001. After you shear, you become 1021. Okay, so shear is that this has changed to this. So what you need to do, just say that shear is that the x-axis fixed and map the 0, 1 2 to 1. Just like that. So this is the answer for the number 3A. Now we move on. Question B. Find the equations of the invariant line through the origin. Invariant line through the origin. The transformation represented by M. So first of all, we need to multiply the product. Just multiply this. Become one matrix. Okay, just multiply them, become one matrix. So you get this one as a 7, 0. And then 7, 0. And then 2, 1. Okay, correct. So this is the product for the two matrices over here. And we want to find the invariant line for this transformation. So we just let our invariant line as y equal to mx. So since in invariant line, your invariant line, after you transform, you still get back this. Okay. So to find invariant line, we just take the matrix over here. Then this is the x, this is the y. After you transform, you get x prime, y prime. Then just replace the y as the mx. Replace the x prime, and replace the y prime as the mx prime. Just like that. And what you need to do just to expand them, you get this one as the 7 plus 2m, x equal to x prime. Then you get the mx equals to the mx prime, equation 1, equation 2. So just take the equation 1 divided by equation 2, you get the 7 plus 2m divided by m is equals to 1 over m. So some students, when they see this, they go and cancel it. Okay, so over here, we don't cancel it. Over here, we will do the cross multiplication. We will have a 7m plus 2m equals to the m, 2m squared. So I continue over here. I get 2m squared plus a 6m equal to 0. Factorize the 2m out. You get m plus 3. So your m is equal to 0 and your m is a negative 3. Okay. Then therefore, your invariant lines will be the y equal to 0 and y equal to negative 3x. So this will be the answer for the question number 3b. Moving on, we have question 3c. Area of triangle DEF transformed by M, and it will become triangle PQR. So this is the object, this is the image, and the M is a transformation. So they are telling you that the area of the image is 35 cm square. They want you to find the area of object. So what you need to do is to write down the relationship of the area of image and area of object. So the relationship between area of image and area of object is area of the image PQR is actually equal to the modulus of a determinant M multiplied by the area of the object. We already have the area of PQR, which is 35. Determinant of M, modulus. So the M is referring to the M here. How do you find the determinant? The determinant will be 7. Just straight away, just put 7. Multiply by the area of DEF. So therefore, your area of the object is equal to the 35 divided by 7. You get a 5 cm squared. Done. This will be the answer for the number 3C. Okay, so now we're moving on. Question number 4. Okay, now we take a look at question number 4. A, prove by mathematical induction that for all positive integers, the series over here is true. The relationship is true. So what you need to do is just to say that when the n equal to 1, so you have the series of the r from 1 until 1, that will be the 1 square. And if you put the n as a 1 inside here, it will also give you a 1. Okay, so this one is true for n equal to 1. Then the second step is assume true for n equal to k, which means that the sum from 1 until k, it will give you 1 over 6k, k plus 1 and 2k plus 1. These are the first basic 2 steps. Now we need to make the n become k plus 1. So that means the series here will become k plus 1. So it will be the same as the sum from 1 until k plus the additional k plus 1 square. Okay, no need to have so many brackets here. Just add one more term. Okay, so now your job is to make this become k plus 1, is to make this become k plus 2, is to make it become 2k plus 3. This is our job, our target, our expectation. So how do you do it? We just copy the result here, put it inside here, and expand or simplify. So over here, this one, it will be 1 over 6k, k plus 1, 2k plus 1 plus the k plus 1 square. We try not to expand them first. We try to see whether we can factorize anything. So if you factorize, these are the common factor that you can do it, and you get this. Then after that, you expand. You get the 2k squared plus the 7k plus the 6. Okay, we try to factorize it. Okay, so this is what you have. So this is actually the target that we want. Okay, this is the target that we want. So we just say that this one is true for n equal to k plus 1. N equal to k plus 1. And a conclusion, by the PMI, series over here where the r from 1 until n is equals to 1 over 6n, n plus 1, and 2n plus 1 for all positive integer. Okay, just like that. This is the answer for the number 4A. Okay, so now we move on to the 4B. 4B, they're asking you to use this identity to show that this sum is equivalent to this. So this one looks a bit complicated. Huh? So what we can do now is we start from the equations here, which is a 2r plus 1 power 5 minus a 2r minus 1 power 5 is equivalent to this. We just put the sigma over here. From r until 1, from 1 until n, from 1 until n. So this part we can use the so-called method of differences. I will swap lah. These two I will swap. I will write it on left hand. The right hand terms I will write it on left hand. So now it will become this. This one will become this. This one will become this. And is equals to the, you replace r equal to 1 inside, you get this one as 3 power 5 minus a 1 power 5. Okay, so maybe you should do it like this. Plus the, if you put r equal to 2 inside, you will get 5 power 5 minus a 3 power 5. If you put r equal to 3 inside, you get 7 power 5 minus a 5 power 5 dot dot dot, because you can see that the pattern will cancel the term in such a way. Then we will need to show until the last one is a 2n plus 1 power 5 minus a 2n minus 1 power 5. Then the last second term is 2n minus 1 power 5 minus a 2n minus 5 minus 3 power 5. So the cancellation pattern will behave in such a way until here. So at the end, your left hand, it will become this. Apply the result from the part A. Apply the result from part A. You will get this one as a 40n n plus 1. Then this one is a 2n equals to the 2n plus 1 power 5 minus a 1. Okay, so now what you need to do is, oh, sorry, I make a mistake. This formula is wrong. From the part A result, I copied the result wrongly. So this one is a 80 over 6 of n plus 1, and 2n plus 1. It's the 2n. Okay, so now I just need to remain this power 4, r power 4 at the left-hand side. The rest of the thing, I just move it to the right-hand side. I get 2n plus 1 power 5 minus the 40 over 3n n plus 1, 2n plus 1, 10 minus the 2n minus 1. So we can actually over here, I just need to factorize the 2n plus 1 over 3 out. Then this one will become 2n plus 1 power 4. Then this one will become 40n n plus 1 minus the minus a 3. Yeah, just like that. Then I bring the 160 to the right hand side. This one using the binomial expansion. So I got 3. Using the binomial expansion, I get 48 n power 4 plus the 96 n cube plus the 72 n square plus the 24 n plus 3 minus the n square minus the 40n minus 3. So this expression is a bit long, so you have to be careful when you expand and simplify them. It's very easy to make careless mistake over here. So at the end, when you simplify everything, you can see that you have a 21, 2n over 2n plus 1 over 480. Then you get this one as the 48 n power 4 plus the 96 n cube plus the 32 n square minus the 16n. So now we actually can just factorize the 3 factorize the 16. Okay, so factorize the 16 out, then you get this. Also factorize the n out. So this one is kind of time consuming. So this one you get 16n cubed. No, 3n cubed. Factorize the 16n plus 6n squared plus 2n minus 1. Okay, so to save space, I direct factorize everything for you already. So you get this one and 1 over 30n, 2n plus 1. This one is the n plus 1 and 3n squared plus 3n plus 1. Okay, so we need to arrange these two, swap them. So to save space, I direct swap it. It will be n plus 1 and 2n plus 1. Okay, so this is the answer that they wanted to show. And they call this one Sn. And C is that the limit of n goes to infinity of Sn divided by S5, n5, n to the power 5. So it will be 1 over 30, n plus 1, 2n plus 1, 3n squared plus 3n minus 1 divided by the n power 5. So at the end, you get this 1, 1 plus 1 over n, 2 plus 1 over n, 3 plus 3 over n minus a 1 over n squared. So when the n approaching to infinity, you get this one as the 1 over 5. Okay, so this is the answer for the question number 4C. 4, right? Yeah, number 4C. So now we move on to the question number 5. Okay, now we take a look at question number 5. The line L1 and L2 has the equation like this. So I write down the L1, the L2. I usually will using the matrix form. It will be 1, 4, negative 1 plus the lambda of 0, 1, negative 2. My L2 will look like this. Negative 3, 4, 0 plus the mu of the 1, 2, 1. They want you to find the shortest distance between L1 and L2. So what you need to do here is that, first of all, you take these two vectors and you cross them. So this vector is a 0, 1, negative 2, 1, 2, 1. So if you cross product, you will get 1 plus 5, 5, 5. Then this one is the negative 2j. Then this one is the negative k. Okay, this is the cross product. Then we let this is called OA. And the second line, it will be called OB. Find the directional vector of AB. And you get this one as the B minus A. OB minus OA, negative 4, 0, and 1. So the formula, the shorter distance, it will be I call this one normal, N. So it will be the AB dot with the N modulus divided by the magnitude of the normal vector. This is the formula. So it will be like this. What is your n? N is a 5, negative 2, negative 1. If you find the magnitude, it will be 25 plus 4 plus 1. Then the AB is negative 401. So when you press a calculator, you get negative 20 minus 1. You get the 21 over the square root of 30. Okay, so this is the answer already. That is the answer. Shorter distance between two lines. Maybe we can put unit over here. So now we move on, number B. We have a pi 1 contain L1 and parallel to L2. So you have the plane. This is the L2 parallel, and the pi 1 L1 is like this. So they want you to find the equations of the pi 1. So just now L2 and L1, if you want to find the normal is actually same as a normal here. Okay, this is the normal, 5i minus 2j minus k. So over here, without wasting our time, our normal, just take the normal as, just now is a 5i minus a 2j minus k. Okay, so your equations of pi 1, it will be 4 brackets like this. This is the x, y, z. This is the normal. 5, negative 2, negative 1. So this one is the normal. This one is the point L1. L1 has this point. L1 has a point 1, 4, negative 1. Okay, so 1, 4, negative 1. So you just expand, simplify. 5 plus 1, 6 minus 8, negative 2. Done. This is the answer for the questions number 5B. And now we move on to the question number 5C. Okay. So with number 5C, we have a point 111 lines on the plane pi 2, given that the line of the intersections of pi 1 and pi 2 through the point 0, 2. Okay, and it's parallel to the vector I plus 4j minus a 3k. So the meaning for this one is actually, you can imagine that you have a plane called pi 1, and you have another plane called pi 2. They intersect. Okay, so they say that this pi 1 and pi 2, the intersection, the line over here, this line, is actually parallel to this vector. Okay, so maybe I erase away the pi 1. Okay, so this line, the line that we have here, this directional vector is I plus 4j minus a 3k. And then they say that this line pass through a point called 0, 0, 2. And then they say the pi 2 contain another point called 1, 1, 1. So we can actually connect these two together to form another vector. Then you cross it, you will get a normal vector number 2. So this is the idea for us to find the normal vector for the plane pi 2. So what you need to do is, first of all, we let this one as the OP, as 1, 1, 1, OQ as the 0, 0, 2. We find the PQ. So the PQ will be Q minus P. Okay. So to find the normal number 2, just take the I, J, K of the negative 1 multiplied by 1, 4, negative 3. So this one is a 3 minus 4, negative I. This one is the 3 minus 1, 2 minus 2j. Then this one is negative 4 plus 1, negative 3k. Okay. Factorize a negative out, you get 1, 2, 3. So my normal will be using this. Okay, so I will be using the 1, 2, 3 as my normal vector. So therefore, your equations of plane by 2 will be like this. This one is a normal. This one is a normal. This one is a XYZ. This one is a point. The point is can be 1, 1, 1. So we just choose 1, 1, 1. X plus 2y plus 3z. This one will be 6. So this will be the answer for the question C. This answer will be the question number 5C. That's all. So now we move on. Question number 6. Okay, now we take a look at question number 6. The curve C has the equations of y equals to the x plus 1 over the x squared plus 3. Show that the C has no vertical asymptote and state the equations for the horizontal asymptote. Okay, so these questions actually to show that the VA don't exist, we just need to take the denominator out, let it equal to 0. From here, we just say that it has no real solution. Okay, no real solution. So therefore, the vertical axis not exist. Say no vertical asymptote. Okay, I think we better say no VA lah. Okay. Therefore, no VA shown. And to find the HA, to find the horizontal asymptote, just need to let the y equals to the limit of x approaching to infinity for the whole expressions here. So you can see that at the end you will get 0. That will be your HA. That is the answer for the number 6A done. Then for the 6B, they want to find the coordinates of a stationary point. So to find stationary point, we need to dy dx, keep the bottom, differentiate the top, minus keep the top, differentiate the bottom, divided by the bottom square. Let your dy dx equal to 0. So for dy dx equal to 0, just considering the denominator, this minus this. Just considering the denominator to be 0 will do. So you will get this one as a x squared plus 2x minus 3 equal to 0. Factorize it. Your x is a negative 3 and your y is a 1. Since your x is a 1, sorry. Since we are looking for point, we need to find the y. When the x is a negative 3, what is a y? When the x is a 1, what is a y? By using the calculator, you can find that the y is negative 1 over 6. Same thing goes for the x equal to 1, your y will be a half. So therefore, your stationary point are negative 3, 1 over 6, and 1 half. Okay, so this is the answer for the part B. Then part C, they want you to sketch the graph C stating the coordinate of the intersections at the x-axis. That means we want to find the intercept. Okay, so over here, we just write like this. When the x is equal to 0, what is my y? If you follow the equation x equal to 0, your y is a 1 over 3. And when the y is equal to 0, your x is a negative 1. So your intercept be 0, 1 over 3, and negative 1, 0. Okay, so these are the intercept. So based on the information that we have from part A, part B, and part C joined together, then we can start to sketch the graph. So in exam, you can draw it with your ruler and pencil. You can have a better measurement. Just use a proper scale for you to sketch the graph. So over here, I draw freehand. My graph may not look very nice. This is the intercept. This is the intercept. 0, 1 over 3. 1 over 3 is here. Okay, so these two are the intercept. So your maximum minimum point or the stationary point, -3, -1 over 6, 1 and half. 1 over here, then half is over here. Then -2, -3. -3, you get -1 over 6. -1 over 6. Somewhere here. So your graph will be having a minimum here. Continue until here. Then maximum. Then go back to this. Okay, so this will be the graph for the C. Now we move on to the question D. For the question D, they're asking you to find or sketch a graph of y squared equals to the x plus 1 over the x squared plus 1. So for these questions, we need to make it become square root. That means to sketch this graph is we make it become y equal to the positive square root of x plus 1 over the x squared plus 3. And another one is y equal to negative square root of x plus 1 over the x squared plus 3. I just need to focus on the positive side will do. This one is just a reflections about the x-axis. Okay, so I'm just focusing on sketching the graph of y equal to the square root of the original graph. Okay, so how do you sketch the graph of the original? How you sketch the graph of y equal to the square root of the original graph? So first of all, we need to find that your original is xy, right? Okay. So now if you modify it, it will become x and square root y. Yeah, because you squared it. So your originally stationary is -1, 0. After you modify, it's still -1, 0. Your another and when you square root it, when you have y equal to square root this, inside here must be always positive. So that means this graph over here not supposed to have anymore after you square root it. After you square root it, the graph that is below the x-axis, it will be gone. Okay, so we only have one stationary point to be considered. Now we want to consider the intercept. So the intercept we have, sorry, this is not the stationary. The stationary is 1.5. 1.5. So it will be 1 and then square root and half. So your intercept is -1, 0. After you modify, it still get -1, 0. Another intercept is 0, 1 over 3. After you modify it, it will become 0 and square root of 1 over 3. By right, these are the point that we should have. Okay, these are the point that we should have. But if you square it, because just now I mentioned, still remember just now I mentioned we have positive square root and negative square root. Remember just now we mentioned that we have a positive square root and we have a negative square root. Okay, so that means this, you have another one is a negative square root. This is also, we have another one that is negative square root. So total, we have 5 points after you modify them. Okay, so over here, I do not want to make it so messy. Okay, I just explained to you the concept over here. So in exam, when we write down the point, we straight away write the answer will do. There's no need for me to explain it anymore. So detailed over here. So we just need to write down your stationary point. Just now I told you is 1 and square root of half. Another one is 1 and negative square root of half. Then your intercept, just write down negative 1, 0, 0 and square root of 1 over 3, and 0 of a negative 1 over 3. Negative 1 over 3. So these are the 5 points that we have. So based on the 5 points that we have, we slowly, carefully put them inside the diagram. Okay. So you have a negative 1, 0 is still here. This one, it will become positive 1 over square root 3. And the reflections will be negative 1 over square root 3. You have positive 1 over 2. And you have a negative 1 over 2. And this will happen at the 1. This is the maximum. Now it will be reflect over here. Intercept. Intercept. So actually the graph, when you draw it, the graph is actually, if you consider the positive directions, the graph will be like this. Now that you reflect. Okay, after that you reflect. So if you reflect about the x-axis, then if you combine them together, then your graph will be like this. Okay. Now again, apologize for my poor drawing because I didn't draw according to the proper scale. So my graph looks not so nice. Okay, so your graph supposed to be like this. Okay, your graph supposed to be like this. Okay, so this will be your graph after you modify them. Okay, so this will be the answer for the D. And move on. We have the question number 7. Okay, now we take a look at question number 7. The curve C has the polar equations r squared equal to the sine 2 theta cos theta, where the theta in 0 to pi, inclusive from 0 to pi. Sketch the curve C, state the equations of the line of symmetry. So for this question, actually, we do not have any shortcut way. So for this, usually we just need to build the table. This is the theta, this is the R. So we just need to put the 0 here, then pi over 6, pi over 4, then pi over 2, pi over 4, then pi over 3, pi over 2. And after that, you have this one as the 2 pi over 3, pi over 4, pi over 6. So you go and find out each and every one of the value. And then after that, you plot it on the graph. So to save time, I will not going to calculate all the value here for you. So this one, you can just try to do it yourself. Okay, so actually you can just refer to the mark scheme on the graph. How does it look like? So over here, I just give you a brief kind of the graph that you will get. Okay, So this one, your theta is a 0, theta is a pi over 2, and your theta is a pi. So you can actually draw this pi over 4. Theta is a pi over 6, then pi over 3. Then you have, I draw freehand, so I didn't measure the angle correctly. So this is just a rough idea only. So in exam, you please remember to do it properly for yourself. This one is a theta equal to the 5 pi over 6. So after you plot everything, correctly, by right, you will get the graph that look something like this. You will get a graph that look something like this. Okay, so if you want to get a better graph, you just refer to the answer from the mark scheme will do. So over here, you can see that the line of symmetry is over here. Okay, so you can just say that the line of symmetry is theta equals to pi over 2. Just like that, done. Then after that, we draw the, we go for the part B. So for the part B, they want you to find the Cartesian equations of the C. So this one actually is not difficult. Our R square is given as the sine 2 theta, cos theta. So you just make it become single angle. It will become 2 cos theta sine theta, cos theta. Then you make it become 2 cos square theta sine theta. That is your R square. I multiply R power 3 here to make it become R power 5. Then over here, you will get 2R cos theta square and R sine theta. So R cos theta is a x, R sine theta is a y, and the R is the square root of x squared plus y squared. So you will get this. And leave the answer like that. That is good enough. Okay. Or if you do not want the power to be fractions, you can just square both sides. Leave it the answer like this is also okay. So this will be the answer for the B. And now we move on to the C, area enclosed by C. To find the area enclosed by C, because you can see that this is a symmetrical line. So this area over here, the area that you have over here, and the area that you have over here are the same. You just need to multiply one. Just calculate the area of one petal, then multiply 2. So over here, I just take 2, multiply the integrate R square the data from 0 to pi over 2. So this can cancel. You will be integrating 0 to pi over 2. Your R square, the question already give you the R square is a sine 2 theta cos theta. There's a 2 in front. So I just need to expand them. And just now, I get 2 sine theta cos square theta d theta. So this one just integrate. I'm using the formula of f prime x fx power n. I'm using this formula to integrate. So at the end, you get this as the negative 2 cos cube theta over the 3. 0 to pi over 2. Oh, I'm using this formula to integrate. At the end, I get this result. Okay, so now you substitute the value inside. Pi over 2, you get 0. This one you get a 1. So at the end, your answer will be 2 over 3 unit square. So this is how you find the area of the curve C. Now we move on to the question D. The greater distance from the pole. That means we are looking for the Rmax. So Rmax, need to find the RD theta equal to 0. Okay, we need to find the RD theta equal to 0. So we will go back to the equation again. Our polar equation, it will be R square equals to the 2 sine theta cos theta. So in order to differentiate, oh, sorry. Make a mistake, just now. There's no 2 over here. There's no 2 over here. I make a mistake. This one got 2. Because after I using the double angle, there's a 2 in front. My apologies on that. Now, we move on. Okay, just now I remember the formula wrongly. The formula itself has no 2 in front. So it's sine 2 theta cos theta. So differentiate it to r d theta equals to the keep the left, differentiate the right, plus keep the right, differentiate the left. Differentiate the left, keep the right, differentiate the left, plus keep the right, differentiate the left. So you get 2 cos 2 theta cos theta. And your the RD theta is equal to 0. That means your 0, it will be negative sine 2 theta, sine theta. It's 2 cos 2 theta, cos theta. So over here, you will get that sine 2 theta, sine theta equal to the 2 cos 2 theta, cos theta. Divide it over here, then you get tangent. So you will get tangent 2 theta, tangent theta equal to 2. Using the double angle formula for tangent, you get 2 tangent square theta divided by 1 minus tangent square theta, you get a 2. Then just try to simplify these equations. The 2 can cancel. No need to have so many 2 here. Okay, so from here you will get that tangent square theta is half. Tangent square theta is a half. So your tangent square theta is a half. And your tangent theta will be plus minus 1 over sec 2. Okay, so we consider positive sec 2 first. I will need to use this triangle. It will be 1 over sec 2. Then this one Pythagoras theorem, you get a sec 3. So your Rmax is a sine 2 theta cos theta using the double angle formula. So from this triangle, you can just put it in. Then you get this one as a 2 sine theta cos square theta. Simplify it. You will get your R equal to the 4 R square equal to the 4 over 3 sec 3. Or you can write it as a 4 sec 3 over 9. Then your R is equal to the square root of 4 sec 3 over 9. Your R to be positive. Or you can simplify them become your Rmax. Still can simplify further. 2 over 3 of 3 power 1 over 4. That is your Rmax. Now what about tangent theta equal to the negative 1 over sec 2? For tangent theta equal to negative 1 over sec 2, we will be using the relationship again. r square equal to the 2 sine theta for square theta. Okay. So for this case, that means your theta is in the second quadrant. It's actually obtuse. Okay, obtuse. So your theta is obtuse in the second quadrant. Your sign will be positive. Still using the same triangle, but the positive negative sign have to change. So you can see that this answer will remain the same as just now. So you still get the answer same. R max is still the same answer. So that means there's no need for you to consider the tangent theta equal to the negative 1 over 2. Okay, so I think just enough, like this is good enough, but want to be safe, you need to verify it again for the tangent theta equal to negative 1 over 2. So that's it. And this is the last part of this question number 7. I will stop the video here. I'll see you next time. Bye-bye.